All right, so I have shown you that I have downloaded the McMaster website screw. All right, the 3D step file, and I have saved it in my location wherever I'm going to save all the files. Okay, and obviously I'll be attaching the step file in the resources. You can directly download, or you can directly visit to the website and you can download this part. So this is the number which you can refer, 960015 18256. You can just search over here, you'll be directed to this screw. And you can see an icon over here which is SW, and you might not be getting this one, the symbol over here. This is because I have another software named as SolidWorks being installed in the machine which I'm using for recording this course. So you might be getting something like this with name and .step. So don't get confused, don't worry about it. You can just directly import this model in Creo Parametric as well. Step files are generalized CAD files which can be imported in any softwares, but it is difficult to edit step files because they are already completed. They cannot be edited in the respected softwares whichever we are importing them with. Now, as a part of our connections or as a part of our assembly, I will be adding this particular screw which I have saved in my working directory. By default, it will not be visible. The step files will not be visible. We have to go to the type and go to all files, and you will be having this step file being represented as .step step. Click on import, and it'll ask you to give a file name. You can just press OK. The default file name will be assigned to it, and by mistake I've selected some surface, so I'll just click on remove. Now you can see that I got the step file, or I have the step file being added over here, or the screw being represented over here. Now what are the different constraints which I have to follow is, the first thing is I should match this surface, okay, with this surface. I'll be selecting, it's not selecting, yeah, this surface with this surface, and they have to be coincident. Okay, and next one is I want the cylinder of this screw to match the cylinder of the hole what we have, and now they're coincident. Okay, let us just press OK as of now, and let us also go to view and change the color of the screw what we have added in the top down or in the assembly. Now I'll just go to these sections and create another section where the screw is being added. Okay, now you can clearly see that the screw is not at all being in contact with the tapped hole what we have created. It is restricting itself in the clearance hole, and the next thing is there is this head of the screw popping out of the object. Now generally this is not desired. The first thing is there is no connection happening. Second thing is the screw head shouldn't be coming out. How can we place this object? It doesn't look good when the screws are being popped out. The screws should be hidden whenever the user is using this object. Therefore, we have to modify the boss which we have created for the lower cover in a way that allows the screw to move inside and mate the surface or self-thread the surface of the tapped hole, and also the complete head of the screw must be hidden inside. So how do we do that? Okay, I'll just take a normal view again, and I'll come back to my default explanation process by using the snipping tool. All right, so we have the screw being present over here. Now I need to modify the lower casing or the lower cover. All right, the lower plastic part what we have, and what do I need to do is I need to enlarge the surface of this hole, something like this. Okay, firstly I need to do this so that the screw will be shifted inside, or the screw bolt will be shifted inside, and obviously this will be coming somewhere over here. So there will be some interaction of the threads with the material over here. All right, and that is the first thing what I need to do. So basically I'm enlarging the hole over here at this region. Now when I'm enlarging the hole at this region over here, you can see the thickness of this surface. Okay, the thickness of this surface will be extremely low, so we shouldn't have this non-uniform thicknesses available in the model. Therefore, what do we need to do is we need to add certain material like this. All right, So adding of this material will basically create a kind of what do you call, smooth surface in this fashion. Okay, so this material will be shaped in this, the final material will be shaped in this. Let me change the color. You'll be having material present in this way, kind of counterbore. This will be uniform. Okay, whatever is the thickness of this one, we need to add that much amount of thickness over here as well. All right, and then this will be continued till here. All right, so this will be a little confusing in the sketch point of view, but let us just try to work. You just work along with me and you'll be understanding the idea. All right, now first and foremost thing is we must understand how much should we dig in, or how much what should be the diameter of this hole. The diameter of this hole, whatever we are being creating at this moment, should be larger than the diameter of the screw head, and the diameter of screw head is mentioned over here, that is 0.27. so we can just keep this as 0.3. okay, that will be the first job. And what should be the depth of this one? What should be the depth? The depth should be larger than the width of this screw head, that is 0.097. so we can just keep it as 0.12, something like that. We will just see. Okay, I'll be coming to the lower casing or the lower cover. What I have, the lower case, I'll be selecting one of the holes, select the surface, go to reference, get a center point, and the diameter of this should be greater than 0.27. let us just assume it as 0.3 at this moment, and it should be on the other side. But before that, what should be the depth of this one? This is 0.097. we will maintain it as 0.11, but on the other side material should be removed. All right, now let us come back to our assembly, and you can see we got an enlarged cap over here, or a gap or a hole, which will allow us to push the screw inside. I'll come back to the constraints or the model tree, edit the screw again, and the first constraint is with respect to the surfaces. The surface was mating this surface, isn't it? So I'll just right click them and delete off. Now the screw is free to move up and down. I'll select the surface of the screw, the inside surface, and I'll mate it with this surface, and I'll make them coincident or coplanar. Now you can see that the screw has inserted inside. But do you think that there is enough engagement of the screw with the upper casing or the upper cover? I don't think it is sufficient engaging. You can see only one thread is being engaged with the upper material. Now you have two options over here. You can increase the depth of this to push it inside, or you can also increase or download another screw whose length is greater than 1/4 inch. We have selected 0.25 inch. You can just go with something larger than that, maybe half an inch or less than half. But I would want to increase the depth, because the screw is still very closer to the surface. Let us just push it inside. All right, so I'll come back to the lower cover, and I'll go to the depth, edit it, and make it as 0.17. press OK. Come back to the assembly, and the software doesn't automatically push it inside, even though we have the surface and the surface in contact when we have assigned the constraints. What do we need to do is we just need to click on edit definition, and automatically moves upward. Just press OK. Okay, so there is a slightly more better engagement in comparison with this, but nevertheless the engagement is quite less. I mean, it is better if we download a little lengthier screw. We can just come back over here, and yeah, I have selected 1/4 inch, right? Now where is that screw? Yeah, it was this one. So we have this number 6 1/4 inch. We can go with 3/8 inches. Okay, and we can select this one, download it, I'll just paste it at the desired location. Come back to Creo Parametric, and I'll just go above this one, so that is being removed automatically. I'll just go to assemble, turn on, and what was the second one? This is 256, so this is 665. Import, press OK, and we have this one present over here. Oh, it's not visible. I'll just open in separate window. Sometimes there are graphical issues, so this should be coincident. Okay, I'm in the sectional view, right? So the parts which are on the left side of the section view will not be visible. They have to be moved to the right side. I'll just do that thing for you to understand. Here it is. Okay, so first thing is this surface should be in contact with the surface. Next thing is the cylindrical surface must be in coincident with this one. I'm sorry, I'm selecting something else. Okay, let me do one thing. I believe that is tapered, so it is not perfectly a perfect cylinder. I'll just zoom out a bit. I'll select this circle and this circle. Now they are coincident. Okay, so coincident in the sense the axis of the screw and the axis of the hole what we have created will be in line. Okay, they'll be coincident. Nevertheless, you can select the interior circle, but when I was selecting the interior circle of the screw, I was getting a tangent option automatically. That means this is not a perfect straight cylinder, it is tapered. So I have selected the outer profile of this one and mated with any of the circle, either the clearance or the tapped hole. Now this looks good for me. I mean, you can clearly see that there is extremely better thread engagement in comparison with the previous one. Let me change the screw color, and you can clearly see that the screw is in contact with the surface or engaging with the material of the surface. Now I need to add up. Let me turn off the section view. First thing is I need to add up the same feature on the other parts of the lower cover. So I'll just come back to the lower cover and edit this hole which I have created and mirror it on the other sides. All right, let me select this, mirror, it is on the other side. I didn't select them. Mirror on the other side. All right, now we can come back to the assembly and we can select this, right click, repeat, select the two constraints what we have used. I've explained this in my assembly module, so I need not explain much of it. The first thing is the surface which we have selected, and second one is the cylinder. You'll be automatically placing the screw at that location. Surface and cylinder, surface and cylinder. Press OK. Now you can just select all this, screw, view, change the color. All right, and if you want, you can just right click, group them together, and just name them something. 6 we have used in 33, I believe. Okay, it's not a valid name. So I'm just writing number 6. All right, now it's not always desired to name it. I'm just doing it for simplicity, so don't just get confused why it's not working. But we have added something over here. We have added the screw. Now the two covers can be assembled appropriately. Okay, now what are the surfaces of contact? The surfaces of contact are the bosses. Okay, and why am I getting a interference? Am I getting an interference over here? Yes. What about this side? Yes, I mean, you can see the boss is still interfering. but what is the amount of interference? Let me just measure. Maybe I didn't measure it appropriately that time. I'll select this, control and select this edge. It's 0.0005. So I'll just come back to the upper casing and I'll select this extrusion and I'll minus it with 0.005. Press OK. Come back to the assembly. Okay, I'm sorry. What's happening is we'll just come re-edit. I mean, the first constraints of the lower and the upper cover are actually incorrect, so we need to assemble them again. So don't worry, I'll be doing everything again. First thing is I'll be importing the lower cover. If you remember, the initial constraints were extremely different. You can just go back to the video and see, but right now we have defined these features, so our constraints should be appropriate. Okay, so this is the first one. Second one is the upper cover. Now I want this surface to touch each other. Okay, and this hole should match this hole. All right, and I'll add a new constraint. I can have this hole with this hole. All right, and now you can see I have a required gap, and we can go to the section view, come to the position where we have the bosses, identify if everything is appropriate or no. The surfaces are touching each other and there is enough clearance between the two surfaces on the outer loops. All right, so this is what we wanted. We wanted the surfaces to touch each other and we want to maintain certain clearance on the outer profiles, and the surfaces will be loaded with the screws. So I will be doing that thing again, but I will be deleting this lower cover. When I'm deleting this lower cover, I can see all the parts which are associated with this will be deleted, but I can go to options and select Control A, go to status, suspend. So the only part will be deleted. Again, for the upper cover, options, status, suspend. All right, I'll delete the first screw what we have downloaded, 0.25, and for this screws I will be adjusting the constraints. So the lower cover is deleted. I'll select remove, delete. This surface will be in contact with this surface and they will be coincident to each other. Okay, open and separate window. This surface or this cylinder will be coincident with this one. Press OK. Now we can simply delete off the other ones and degroup that first one. Now again right click and repeat. So here is the surface, cylinder, surface, cylinder, surface, cylinder. Press OK. Select all of these, change the color to something different. Press Ctrl D. You have the data being present appropriately. I'll just delete off this section. So we are done so far. All right, and let us also change the color of the upper cover to something different so that it is easy for us to compare them. All right, now let us move to the next video and add other set of engineering features on both the covers, add the positions for the buttons of the joystick, and try to complete our assembly to a finished state. Let us move to the next video.